Stats Chapter 10 Test, Part 2, Whiteboard Review. Our first problem says to simplify the square root of 52. I've written the first 12 perfect squares across the top of the screen. So remember that when we're simplifying a square root that's not a perfect square, what we're looking for is the largest perfect square factor. So from the list at the top, the biggest perfect square that's a factor of 52 is 4. 52 divided by 4 is 13, or 4 times 13 is 52. So notice that I've got both of them underneath square root symbols at this point. So the square root of 52 is the same as the square root of 14 times, or square root of 4 times the square root of 13. Now because the square root of 4 is a perfect square, the square root of 4 is 2, my answer is 2 times the square root of 13. So the number that is a perfect square factor, that one in the final answer is not underneath the square root symbol anymore. Problem number 2 is the square root of 72. The largest perfect square factor of 72 is 36. 36 times 2 is 72. The square root of 36 is 6, so in simplest form, the square root of 72 is 6 times the square root of 2. If you're not good at figuring out the largest perfect square factor, just start. If it's 72, 72 would fall here, so start with 64 and try dividing. So 72 divided by 64, it's not going to give you a whole number. Then try 72 divided by 49. That's not a whole number. So keep on going using the division key on a calculator until you find the largest perfect square factor. This next one, 3 times the square root of 60, I'm going to simplify the square root of 60 and leave that 3 alone because it's just being multiplied out front. So the square root of 60, the biggest perfect square factor of 60 is 4. So 4 times 15 is 60. The square root of 4 is 2. So now the 3 that was in front right here is going to be multiplied by my 2 to give us a final answer of 6 times the square root of 15. So simplify the square root part and then multiply by that 3. Another one like that. 99. The biggest perfect square factor of 99 is 9. So 9 times 11. Square root of 9 is 3. So then take that 5 that was out in front and multiply it, and you get 15 times the square root of 11. This next one, you notice we're multiplying, and when you multiply, the commutative property says it's okay to change the order. So I'm going to put the 2 and the 7 together first, and then the square root of 6 and the square root of 8. By reordering my multiplication, 2 times 7 is 14, and multiplying these square roots together gives me the square root of 48. Because the square root of 6 and the square root of 8, they weren't perfect squares, putting them together to give me 48 means that I can simplify and factor the 48 a little differently. So instead of 6 times 8, the biggest perfect square factor is 16. 16 times 3. So it's just a different way of breaking down that number 48 in order to simplify. Square root of 16 is 4. So 4 times the square root of 3, and then I've got the 14 in the front. So I have to multiply 14 times 4, which is 56, times the square root of 3. So the 6 and the 8 up here, you put back together to get 48, and then you factor that 48 differently. Similar to the last one, so I can multiply 3 times 12 is 36, multiply the ones under the root to get 56. And then 56, if I simplify it, the biggest perfect square factor is 4, so 4 times 14 and I've got my 36 here. The square root of 4 is 2. So 36 multiplied by 2 is 72. So 72 times the square root of 14. Now, switching a little bit to adding and subtracting, as long as these are like terms, you can add or subtract the numbers in front. So this is similar to 13x minus 7x, which would equal 6x. You treat the radicals as like terms as long as what's underneath the square root is the same number. So this one, because they're both the square root of 5, 13 minus 7 is just 6. So it's 6 times the square root of 5. So don't change the radical part when you're adding or subtracting with your like terms, just like my example with x. So this next one again, these are like terms. So 11 plus 6 is 17. So 17 times the square root of 3. So those didn't require any extra simplifying. These next few will. So this is kind of putting together all of it, simplifying the radicals, and then combining the like terms. So I am going to simplify all of these square roots. So I'm doing this all at the same time, so it takes less space. 18, the square root of 18 would be 9 times 2. Biggest perfect square factor, 9. 32 is 16 times 2, and 72 is 36 times 2. Now in this problem, you may notice that all of them have a square root of 2 as one of their factors. They don't have to all match, okay? Square root of 9 is 3, and then I've got the 2 out in front. The next one, square root of 16 is 4, and again, I've got a 2 out in front. And then this last one, square root of 36 is 6, and nothing out in front on that one. Okay, so we've got 6 times the square root of 2, plus 8 times the square root of 2, plus 6 times the square root of 2. They are all like terms because they've got the same radical part. So I can add them all together, and adding the numbers in front gives me 20 times the square root of 2. Next one like that. Split the square root of 24, split the square root of 54, and split the square root of 96. Okay, 24 is 4 times 6, 54, 9 times 6, and 96, you might not know this one, 96 falls right here. So you're trying all of these numbers. Starting with the biggest one, you're seeing what can I divide 96 by? 96 divided by what? Equals a whole number. And this one is going to be 16. 96 is 16 times 6. So now, the square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. So this one ends up with all like terms again. So I need to do this multiplying first. So this one is 6 times the square root of 6. Then we've got minus 12 times the square root of 6. And plus 4 times the square root of 6. 6 minus 12 plus 4. Because these are all like terms. So 6 minus 12 is negative 6. Plus 4 is negative 2. So negative 2 times the square root of 6. Next one, same thing. This is the trickiest thing that we've worked on for this part of the chapter. So we have a lot of examples like this. 27, 9 times 3, 50, 25 times 2, and 75, 25 times 3. So 3 times, square root of 9 is another 3. So 3 times 3, square root of 3. 4 times 5, and square root of 2, and 5 square root of 3. Multiplying gives me 9 times the square root of 3 minus 20 times the square root of 2 plus 5 times the square root of 3. Now these are not all like terms, only 2 of them are. So 9 plus 5 is 14. 14 times the square root of 3 minus 20 times the square root of 2. So this final answer looks different from the others because they were not all like terms. One more problem like that. All right, 48 is 16 times 3, 200 is 100 times 2, and 12 4 times 3. So 9 times 4, square root of 16 is 4. 3 times 10, square root of 100 is 10. And 7 times 2, the square root of 4 is 2. So 36 square root of 3 minus 30 square root of 2 plus 14 square root of 3. So again, 2 like terms on this one. So 36 plus 14. Oh, on your review worksheet, hold on a minute. On your review worksheet, this is a minus. I gotta fix this so it matches your review worksheet. Sorry about that. Fix this. So on the review worksheet, this is a minus, not a plus. Okay, so minus. So 36 minus 14 is 22. So 22 times the square root of 3, and then minus 30 times the square root of 2. Okay. Now we're switching over to sine, cosine, and tangent. Remember Sohcahtoa. Sohcahtoa. You can write it like this. Sohcahtoa, if you like to look at it in fraction form, because it can be helpful. Now this one is saying that the reference angle is A. So I'm going to circle that A and then label my 3 sides in relationship to it. The longest side is the hypotenuse. So the hypotenuse is 20. The side opposite that angle A is the 15, and adjacent means next to, so 13 is adjacent. So now sine, if I look at my fraction here, sine is opposite over hypotenuse. So opposite is 15 over hypotenuse is 20. And I can reduce that, dividing them both by 5 gives me 3/4. The next ratio, cosine, is adjacent over hypotenuse. Adjacent is 13, hypotenuse 20. So 13 over 20. And then tangent is opposite over adjacent, so 15 over 13. So those are the 3 trig ratios in fraction form, lowest terms. All right, now our last couple of problems. Again, I'm going to put my Sohcahtoa up here in fraction form in case that's what you like better. All right, so this one, it's our reference angle is the angle that has the degree measure written in it. So notice the degree measure is by angle A. So angle A is our reference angle. It's 42 degrees. Now, the 2 sides that have things labeled, like in relationship to that A, well, 30, this is the longest side, so it's the hypotenuse. Opposite would be over here. There's nothing written. So the x is the adjacent side. It's next to the angle A. So the 2 things that have the variable and the number are the hypotenuse and the adjacent side. So those are the 2 letters that I have to look for in my ratio. So adjacent and hypotenuse are with the cosine right here. So that means cosine is what we're going to use. So cosine 42 degrees over 1 equals the adjacent side, which is x, over the hypotenuse, which is 30. So again, how I determine the ratio that we're using is based on what side this x is and what side this 30 over here is. They're adjacent and hypotenuse, so this is the ratio right here, cosine, that has adjacent and hypotenuse. So the angle measure goes up on top. There's always a 1 on the bottom. So the left-hand side of your proportion is always going to be either the sine, cosine, or tangent ratio over 1 to make it a proportion. So there's always a 1 in this spot right here, bottom left. Now using a calculator, cosine 42 to 4 digits is 0.7431. So now we can solve the proportion. So we're going to cross multiply and divide, like do the butterfly. So we're going to multiply 30. So you multiply the 30 times the decimal, and then you divide by 1, and it gives you your answer, 22.3. Round that final answer to the nearest tenth. So cross multiply, butterfly, fish, whatever method you want to call it. I guess I drew the fish method. You could do cross products if you wanted to do the butterfly. All right, next one. The angle with the 35 degrees is A. So in reference to that, if I look at this triangle's a little bit turned. So the longest side is where the x is. That's the hypotenuse. And then the 7, is it opposite or adjacent angle A? It's opposite. It's all the way across the triangle. It's not right next to the 35. So opposite and hypotenuse you find together right here for the sine. So remember, it looks like this in fraction form. So sine 35 degrees over 1, you always put the 1 under it, equals opposite, which is 7, over hypotenuse, which is x. So the sine of 35 degrees on a calculator, 4 decimal places, 0.5736, put the 1 under it, equals 7 over x. So if we solve this one, our fish, 7 times 1, and then we would be dividing by the decimal. 7 times 1 is 7, divided by that decimal is 12.2. 12.2. Now, if you don't like to do that kind of fish method, I'm just going to show you what it would look like if you solve this doing cross products. It would be like this. So you would do this cross product and then this one. So it would be like 1 times 7 equals 0.5736 times x. 1 times 7 is 7, like this. And then you would divide both sides by that decimal to cancel it out. So in case this is how you learned how to solve proportions, you can do this way as well. So it looks like a butterfly. You can do the butterfly or fish method, but you're just cross multiplying and dividing. The left-hand side always gets either sine, cosine, or tangent, that decimal over 1 to make it a proportion.